So today we're going to do expected frequency, and this is the formula that you got to learn now. So expected frequency is the number of trials multiplied by the relative frequency or probability. So remember, to get relative frequency, it is the frequency all over the number of trials, and to get probability, we use the terminology, it's the number of favourable outcomes all over the total number of trials. So this example here states, a student carries out a random survey of 50 people on a car ownership in his local area. 40 people responded that they own a car. Calculate the relative frequency of owning a car and estimate how many of the 3,000 people in the local area own a car. So the first part we'll do is part A. So calculate the relative frequency. So the relative frequency is the frequency of people owning a car, which is 40 out of the total number of trials, which would be 50. So in this case here then, A would be 40 out of 50. So remember, fraction, we always break it down to its simplest form. So 40 out of 50 breaks down to 4 over 5 or 0.8. That's an 8 there. Okay, so then part B then, they asked you to estimate how many of the 3,000 people in the local area own a car. So that is asking you for the expected frequency, which is the number of trials, which is 3,000, multiplied by, this time we were given the relative frequency, so it's 0.8. So it would be 3,000 multiplied by 0.8, which would give you 2,400 cars. Okay, so the estimate frequency of people owning a car in that area would be 2,400. Okay, so my second example then here states that a fair six-sided die is thrown 60 times, okay, and then we're looking for the expected frequency. But just before I do the expected frequency, I just want to go through this concept of what is a fair six-sided die. So if something to be fair or unbiased, it is if all outcomes are equally likely to occur, then the trial or experiment is considered fair. So that means when I throw that die, there is an equal chance that I'm going to get a 1, 2, 3, 4, 5, and 6. Okay, so the die is considered fair or unbiased. So going back to the questions then that they asked, it says, how many sixes would you expect to get? Okay, so expect to get means we're looking for the expected frequency. So to get the expected frequency, you have to get the probability multiplied by the number of trials. So we're talking about sixes here. So what is the probability of getting a 6 when you throw a die? Well, probability is the number of favourable outcomes all over the total number of outcomes. So favourable outcomes, again, remember, it means what we're looking for. So there's only 1 6 in a die, so that's our 1, out of the total number of outcomes, which would be 6. So the probability of getting a 6 when you throw a die is 1/6. So that's the probability, but we're looking for the expected value, and it's a probability multiplied by the number of trials. So in part 1 then, it's be 1/6 multiplied by the number of trials, which is 60, which would give me 10. Part 2 is how many 2s would you expect to get? Okay, so we have to get the probability of getting a 2 when a fair six-sided die is thrown. So the probability then is the number of favourable outcomes all over the total number of outcomes. So how many 2s are in a die? So it's 1 out of the total again, so that will give me 1/6. So to get the expected value then, it's the probability multiplied by the number of trials. So in this case again, it would be 10. Third one then is how many even numbers would you expect to get? Well, the even numbers in a die are 2, 4, and 6. 2, 4, and 6. So the probability of getting an even number is 3 out of 6 or a half. Okay, so that is our probability. So then we're looking for the expected frequency, which is probability by the number of trials. So you would expect to get even numbers would be the probability, which is a half, multiplied by the number of trials, which is 60, which will equal to 30. So going through another example here, it says one ball is selected at random from the bag shown and then replaced. This procedure is done 400 times. How many times do we expect to select a blue ball and a red ball? So again, they're looking for expected frequency. So for expected frequency, we have to do the probability multiplied by the number of trials. So the first thing I'm going to get is a probability of getting a blue, and then I get the probability of getting a red ball. So probability then is a number of favourable outcomes all over the number of total outcomes. So looking at the bag here, we can clearly see that we have 2 blue balls out of how many balls altogether? So there's 1, 2, 3, 4, 5. So the probability of getting a blue ball here is 2 out of 5. And the probability of getting a red ball would be 3 out of 5 because there is 3 reds, 1, 2, 3, out of a total of 5. So then we're looking for expected frequency because they said how many times you expect to get a blue ball. So that is its probability multiplied by the number of trials. So the probability of getting a blue ball we said was 2/5 multiplied by the number of trials, which is 400, and that works out to be 160. So I expect to get 160 blue balls. The same guy with the red ball. So the red ball is 3 out of 5. Okay, so that's the probability multiplied by the number of trials, which is 400. So 3/5 multiplied by 400 would give me 240. Okay, so going through this example here then, so the first thing you notice is it says this spinner is biased. Now what do we mean by biased? It means that all outcomes are not equally likely to occur. Okay, so we usually try to say that if it's fair or unbiased means all outcomes are equally likely. So this is biased, so you won't get the same outcome for each one. So probability that the spinner would land on each of the numbers 1 to 4 is given in the table below. So to get 1, the probability was 0.35. For the 2, it'd be 0.1. For the 3, would be 0.25. And the 4 to be 0.15. The spinner is spun once. So work out the probability that the spinner would land on 5. So we know that all of probability should add up to 1. So you add 0.35, 0.1, 0.25 and 0.15 and you get 0.85. And you take the 1 minus 0.85 to leave you with x. They did it as equation here, but it's 0.15. So if you're missing a value for probability, you know probability has a scale only from 0 to 1. So this probability had to add up to 1. So you add up the 4 that you had was 0.85 and you take that from 1 to give you the 5 to be 0, the probability of it to be 0.15. So the probability of the spinner landing on 5 is 0.15. Write down the number which the spinner is most likely to land. Okay, so it's mostly likely to land on the biggest value here for the probability. So the spinner is most likely to land on 1 as it has the highest probability. And then the third question, if the spinner is spun 200 times, how many times do you expect to land on 3? So this is expected values. Remember, expected value, it is the probability multiplied by the number of trials. So the probability of landing on 3 was 0.25, so it's 0.25 or a quarter, and you multiply that by the number of spins. In this case it was 200, so it was a quarter multiplied by 200, which would give you 50. So the thing that you have to learn from this example is that bias means that all outcomes are not equally likely to occur. If they give you a table and you're missing a section, you must make sure that the whole probability line would add up to 1. So you add up the values that you have and you take it from 1 to get your missing value. And then to get the expected value, it is the probability multiplied by the number of trials. Okay, so we do this example. So again, we're looking for expected value. So we can see we're given a table and it says copy and complete it. So for the first 4 questions, we're looking for the expected frequency. And the last 2, we're given the expected frequency and we're either missing here, the last one, we're missing a number of trials, and here we're looking for the probability. So at the top of your page, every time you do these questions, I want you to always write down the formula. So we know then that expected frequency is probability by the number of trials. So if we're looking at event A, the probability is 0.8, the number of trials is 100, so what is the expected frequency? So for part A then, that would be 0.18 multiplied by 100, which would give me 18. So 18 fills in here. Part B then, again, we're looking for the expected frequency, which is the probability multiplied by the number of trials. The probability, they said, was 1/20th, multiplied by the number of trials is 260, which will give us the expected value. So just writing that down then, that would be 1/20th multiplied by 260, and that works out to be 13. So the expected value of B would be 13. The same for C, we're looking for the expected frequency, so that would be 0.73 multiplied by 3000, which is the probability but multiplied by the number of trials, and that works out to be 2190. So this is 2190. D then, so D is, they gave you the probability is to be 2/3 of this event, and the number of trials they carried out was 6,600. So what was the expected frequency? So again, it's probability by the number of trials. So that would give me 2/3 multiplied by 6,600. So that would give me 4,400. So 4,400. So they've actually named the fifth guy here D as well. So D then, so we'll say our second D. So this time they gave us the number of trials and they gave us the expected frequency, but we're looking for the probability. So if we're looking for the expected frequency, it's probability multiplied by the number of trials. But if they give us the expected frequency, to look for probability, you divide. So we'll say the second D then, what you do there is you do 30 divided by 1,500, which will give you 1/50th. So that would be 1/50th, because if you multiply 1/50th by 1,500, you get 30. The same for E, okay, so they give us the expected frequency and the probability. We're looking for the number of trials. So in this case, then you have to divide. So that would give me E then, so writing that down then, that would give me E would be 200 divided by 0.16, and that works out to be 1,250. So 1,250. So this example here then would be our last example. So it says a spinner with 20 equal sectors is spun. Each sector of the spinner is coloured blue, red or green. The probability scale shows the probability of the spinner landing on a certain colours. So B is here and R is pointed at this guy on our probability scale. Remember, probability scales goes from 0 to 1. So we can easily fill in all of these guys. So it goes from 0. The next one down here would be 0.1. This one would be 0.2. Then we have 0.3. Then we have 0.4. They gave us 0.5. So the red then would be 0.6, 0.7. This would be 0.8. The last one would be 0.9. And then you have your 1. So remember, you know our probability scale always goes only from 0 to 1. Remember, 0 is impossible if an event is impossible, and 1 if it's certain. So then it says, how many of the sectors are coloured blue? Okay, so blue then we can clearly see is B here. Okay, so it's after the first one. So that is 0.1. So then it is 0.1. So for blue then, the probability is 0.1 multiplied by 20, which is the number of sectors. So that would give me 2. Looking for the red then, okay, so we get the probability of red. The arrow is pointing here. So 0.5. So after 0.5, we said it would be 0.6. So that is the probability, which is 0.6 multiplied by the sectors. So 0.6 by 20 would give me 12. So the last one then is green, okay? So they give us no indication of what would the probability of green would be. But we know that blue takes up 2, red takes up 12 sectors, okay? So if I add the 2 of those guys, my total number of sectors that I have already accounted for is 14. And they told me that the spinner has 20 equal sectors. So green has to be the remaining ones. So green then would be 20 minus 14. So 6 sectors have to be green.